Students, welcome to pre-calculus class today. We're going to have a little different format than we usually do. I'm not going to give notes today, so please listen carefully as to how we are going to do class today. This is math that you should have learned in Algebra 2. And instead of giving you a bunch of exponential properties today, in fact, go ahead, if you would, while I'm talking and write that in your notes. We're going to be looking today at exponential properties. But instead of me giving you all of those words, those properties, we're just going to work a bunch of problems today. All right? So it's review chapter. We're still in the review chapter, section number 2. And what we're going to do today is we're going to look, go ahead and turn your books, if you would please, to page number 14. And we're going to do numbers 1 through 49 odd. That sounds like a lot, and it is actually. It'll take you quite a while. However, there's no teaching video today. So what you're going to do is you're going to watch this video right here. And then this entire video is just going to be working these problems out. I'm not going to actually give you the properties. Again, we're still reviewing from Algebra 2, and we should know this information. So I'm just going to go over it. And if any of you are struggling a little bit with this, I think you'll kind of catch on as we go along as to what we're doing. Okay, so I'm going to pause for a second here. Go ahead and get your books out. Turn to page 14. We're looking at numbers 1 through 49 odd today. And so instead of having a teaching video and then a homework video, we're having just a homework video today. Okay, so if some of you are able to work ahead because you know this stuff and you're finding it boring because you really get it, then work ahead. Do all of them, as many as you can, and then go back and watch this video on the ones that you struggled with. Remember, all of these answers are in the back of your book, so you're welcome to not watch the video, work these out, check them, and the ones you missed, go ahead and come back and watch the video for the ones that you missed. If you are looking at these problems on page 14, you're like, wow, this is like Greek to me, then you'll want to watch all of these problems as I work them out now for you, okay? So this is a homework assignment. It is due. Again, homework is on the honor system, and this will be a long video, but remember, there's no teaching video today. We're just working on problems, okay? Let's go ahead and take a look at number 1. Number 1 says 3 to the negative 7 power. We learned last year, well, in any math class you've learned, you can put anything over 1. So the first thing I'm going to do is put 3 to the negative 7 power over 1. Now, if you'll look at the directions for numbers 1, 3, and 5, go ahead and look at your book. It says write an equivalent expression with no negative exponents. So our goal is to get rid of this negative sign right here. Okay, so here's what we're going to do. What we've learned in algebra is that you can move the base, which is a 3, and the exponent, which is a negative 7. You can move that to the bottom of the fraction or the top as long as you change the sign of just the exponent. So watch what I do. There's a 1 already in the denominator, so I leave that 1 down there. And then I bring this 3 down to the bottom, and when I do, the 7 becomes positive. Do you see how I did that? This is called the base. This is called the exponent. And what we've learned in the past is, hold on one second, please. That was the wrong button. Let me quickly change that. There we go. What we've learned in the past is this number here is the base and this number here is the exponent. And if I pick them both up and move them down to the bottom, or if they were in the bottom and I moved them up top, notice the 3 doesn't change, but the 7 changed, the exponent. So I move the 3 to the bottom, the 7 becomes positive. There's nothing left up top, so I can put a 1 there if there's nothing left. And then my final answer would simply be this. 1 over, now 1 times anything is just itself, so 1 times 3 to the 7th power is just 3 to the 7th power. And that's all you have to do for these first 3 problems. They just want you to rewrite the problem so that it has no negative exponents. Okay, let's take a look at number 3. Now, this one's not too difficult. I have x to the negative 5 and y to the negative 4. So if I pick up this y to the negative 4 and I bring it up top like that, then my 4 is going to become positive. And if I take this x to the negative 5 and I bring it down here to the bottom like that, then my 5 is going to become positive. And that's it. We're finished. All that you're doing on the first 3 problems is you're writing them so that there are no negative exponents. Now, let me say one more thing. If this 5 here in the original problem would have been positive, then you wouldn't have to move the x. You would leave the x up top in the numerator, and you would bring the y up top, okay? But in this case, because the 5 was negative, then we bring the x down to the bottom, the y up to the top, and both of the exponents are now positive. Let's take a look at number 5. Okay, on to number 5. Really, this is identical to the last problem, okay? I have m to the negative 1, so if I bring it down to the denominator, it becomes a positive 1. I have n to the negative 12, so if I bring it down to the denominator, it becomes positive 12. And I have t to the negative 6. If I bring that up to the numerator, it becomes t to the positive 6. And we're finished. Remember, for the first 3 problems, all they wanted us to do was rewrite the problems so that there were no negative exponents. Okay, let's continue on. Now, if you'll look in your book at numbers 7 through 49, as you can see, they really get difficult as we move toward the end of this section. But in number 7 through 49, the directions say one word, and that's just simplify. And of course, simplify means to take the problem as far as you can. Now, let's start off with this problem here, number 7. 18 to the 0 power. A lot of students think the answer would be 0 because you're taking 18 to the 0 power. However, we've learned in Algebra 2 and Algebra 1 that anything to the 0 power equals 1. So 18 to the 0 power is 1. That's it. We're finished. Anything to the 0 power always equals 1. So the answer is 1. Number 9. Now, here's something we learned in Algebra 2 and Algebra 1. And so we're just reviewing. X to the 9th power times x to the 0 power. What we learned is this. Whenever you're multiplying like bases, and we do have like bases, here we have a base of x and a base of x. So whenever you're multiplying like bases, you write that base one time like that, and then you do not multiply the exponents, you actually add the exponents. So 9 plus 0 is 9. All right, so let's go over that again very quickly. I have x to the 9th power times x to the 0 power. When you're multiplying like bases, you write the base one time and you add the exponents. So your answer is x to the 9th. Okay, we're going to practice on a lot of these. Again, I don't know where all of you are in your math. Some of you had me in the past, some of you haven't. And also, you might be a little rusty since you've had the summer off. So let's just go over this and see how we do. Okay, same thing, number 11. My base is a 5. My base is a 5. So we are multiplying like bases. So whenever you're multiplying like bases, you write the base how many times? You write it once, and you add the exponents, excuse me. So 8 plus negative 6 would be 2. 8 plus negative 6 is 2. And of course, 5 to the 2nd power is 25. So there's your answer. All right. Hopefully this is making sense. All right, let's take a look at number 13. Once again, the exact same thing. Here we have a base of m and a base of m. So we're multiplying like bases again. When you're multiplying like bases, you write the base once and you add the exponents. Well, negative 5 plus 5 is 0. And we learned earlier about 2 problems ago, anything to the 0 power is 1. So m to the 0 power is 1. So your answer is 1. Well, Mr. Earhart, that's a variable. That's a letter. Is that okay? Sure. Anything to the 0 power is 1. Okay, let's continue on to number 15. Now be careful on this one, okay? Whenever you're asked to simplify problems like we're asked to do here, you never want negative exponents in your final answer. So let's kind of see what happens here. First of all, we have a base of y and a base of y. So we're multiplying like bases. So we write the base once and we add the exponents. So we have y to the negative 4 because negative 3 plus 7 is negative 4. But hold it, we think this is our final answer, but we do not want a negative exponent in our answer. So what we're going to have to do next is now we're going to take this y to the negative 4 and we're going to put it over 1. You can put anything over 1. Now the reason we're going to put it over 1 is we really would like to have a fraction. if you have a negative exponent and you want to get rid of it, it's really helpful to have a fraction. Okay? So now that I put the fraction over 1, let me draw an arrow going down. We'll finish it right here. I can take this y to the negative 4 and I can bring it down to the bottom of the fraction so that my negative 4 becomes positive. So I bring the y down to the bottom, my 4 becomes positive. Of course, what was already down here in the bottom, it looks like right here, there was already a 1 in the denominator, so I have a 1. Nothing left up top, so I put a 1. And it looks like to me your final answer is going to be, we'll go this direction now, is going to be 1 over y to the 4th. Now I definitely put some extra steps in here that you don't have to do, but I'm really trying to break this down and make it pretty easy, okay? So 1 times anything is just itself, so 1 times y to the 4th is y to the 4th. And there's our answer right there, okay? Not too bad. Let's take a look at number 17. Okay, now we're multiplying 3 like bases. We have 7 to the 3rd power, 7 to the negative 5 power, and 7 to the, well, there's no number, but I can put a 1 there, 7 to the 1 power. Okay, well, I have all like bases, a 7, a 7, and a 7. So we've learned in the past, whenever you're multiplying like bases, you write the like base 1 time, so there's my 7, and you add all of the exponents. You add them. So 3 and negative 5 is negative 2, plus 1 is negative 1. So we have 7 to the negative 1. Now you think you're finished, but hold it, we have a negative exponent. And you never want a negative exponent in your final answer. So remember what to do. We put this whole thing over 1, all right? And then we bring this 7 down to the bottom. Now when we do, the 7 doesn't change. The negative 1 is what changes. Okay, don't forget that. The 7 stays the same. So I have 7 to the positive 1, and there's already a 1 down here in the bottom. So I'm going to go ahead and put a 1 right here, and there's a 1 up top, of course, because there was nothing left, so I put a 1 up top, and my final answer is 1 over 7, because a 1 in the numerator stays 1, and down here I have 1 times 7 to the negative 1. Well, 1 times 7 to the negative 1 is, or excuse me, I have 1 times 7 to the 1 power. Well, 1 times 7 to the 1 power is 7 to the 1 power, and 7 to the 1 power is just 7. Now you could have very easily skipped this step here if you wanted to, and went right from here to here if you understand how to do that, and that's totally fine. I'm just trying to make this as easy as possible, okay? All right, let me quickly grab a drink of water here, excuse me. I'm doing a lot of talking here. Voice gets a little dry. Okay, let's move on. Number 19. Now, please watch this carefully. Notice what we do here. Are you ready? This is called a coefficient. This is called a variable. This is your exponent, okay? This x is also called your base. If you want to call it the base, that's fine. Now, if you'll look carefully at what we have, please watch this. We have 2x cubed times 3x squared. Now, obviously, we have an x times x, and you should know what to do with that. We've just done a bunch of those. Whenever you're multiplying like bases, you write the like base 1 time and you add the exponents. Does everybody see that? Your x to the 3rd times x to the 2nd gives you x to the 5th. You add your exponents. But when you have a coefficient out front, like a 2, and a coefficient out front, like a 3, you do multiply those. So your answer would be 6x to the 5th. Let me try to circle that again. 6x to the 5th. Does everybody see where the 6 came from? 2 times 3 is 6. And hopefully everybody sees where the 5 came from. 3 plus 2 is 5. Whenever you're multiplying like bases, you add the exponents, okay? So let's try another one. Okay, this will be a little more difficult, so please pay attention. We have negative 3a to the negative 5th, 5a to the negative 7. Now we're multiplying these. They're side by side. So the first thing I do is I multiply my coefficients, my negative 3 and my 5. And that would give you a negative 15. Does everybody see where the negative 15 came from? Sorry about that. I apologize. Give me one more chance at this. All right, so hopefully everybody sees where the negative 15 came from. Now let's take a look at your a's. You have a to the negative fifth times a to the negative 7. Well, that would be a to the negative 12, because whenever you're multiplying like bases, you add the exponents. Now again, you might not have thought of that, but do you see it okay? Hopefully you do. If not, you got to go back and practice these until you get this. Now, don't miss my next step. I need your full attention. Please pay attention to this, okay? The a has an exponent of negative 12, and you know by now we don't want negative exponents. However, the 15 does not have an exponent of negative 12. It does not. You can't see the exponent of the 15. It's 15 to the 1 power. It's like it's invisible, okay? So if we're going to get rid of this negative 12 and we want it to become a positive 12, if we're going to do that, we don't need to mess with the negative 15. Leave it alone. The negative 15 has a positive exponent. Even though you can't see it, it is a positive 1. So here's what I'm going to do. I'm going to put a fraction bar. I'm going to leave my negative 15 up top. I'm going to take my a to the negative 12, and I'm going to bring that down to the bottom. Okay, and when I do that, I now have a to the positive 12. And that is the correct answer. Well, Mr. Earhart, you've got a negative 15 up top. Yes, we do. You're right. But I never said that you couldn't have a negative base. What I said is you cannot have a negative exponent. And your exponent here is 12, and that's positive. And your exponent here is 1, even though you can't see it. And that is also positive. So we are totally within the bounds of what we're supposed to do. All right, number 23. Boy, they're getting tougher, aren't they? This is a really good challenge for you guys. All right, here we go. First of all, we're multiplying these two expressions. 5 times 3 is 15. Now we have a base of a and a base of a. When you're multiplying like bases, you write the base one time. So hold on one second. My mimeopad is messing up here. Sometimes it does that. All right. Whenever you're multiplying like bases, you write that base one time. So there's my a. And then, of course, when you're multiplying like bases, you add the exponents. So I have a 2 and a negative 3. I'm going to add those, and I will get a negative 1. Now let's look at our b's. I have a b and a b. Now, students, there is no exponent with a b, so we understand there's a 1 there. So it's b to the 1 power, b to the 4th power. So with that in mind, I would now have b to the 5th power. Now, you're not finished. We have a negative exponent. Is this exponent here negative? No, it's a 5. Is this exponent with a 15 negative? No, it's a 1, even though you can't see it. But is this exponent right here negative? Well, yes, it is. So we have to move the a, which is the base, and the negative 1 down to the bottom of the fraction. So I have 15 b to the 5th. We're not going to move those. They have positive exponents. But the a goes down to the bottom. And when I do that, negative 1 becomes a positive 1. And that, students, is your answer. 15 b to the 5th over a to the 1. All right, let's continue on to number 25. Okay, same type of problem again, which I love. This is great. We're practicing. No different than sports that you play or any other things that you're into, musical instruments, whatever. Practice is how you get better. So we're multiplying these two groups together. We have a coefficient of 6 and a coefficient of negative 7. Let's go ahead and multiply those together, and you will get a negative 42. Now we have an x times an x. Whenever you're multiplying like bases, you write the base once and you add the exponents. Now we have a y times a y. Whenever you're multiplying like bases, you write the base once and you add the exponents. So hopefully you're seeing where the negative 1 came from and the negative 4. We're adding exponents. Now, does the y have a negative exponent? Yes. Does the x have a negative exponent? Yes. Does the 42 have a negative exponent? No. It's a 1, even though you can't see it. So the only thing I need to move I'm not going to move the negative 42, it stays up top, but I've got to bring the x down to the bottom so that it becomes a positive 1, and I've got to bring the 4 down to the bottom so that it also becomes a positive 4, and that will be your answer. That's number 25, negative 42 over x y to the 4th. Okay, moving on to number 27. Now, this is, please be careful, students. Watch carefully. We haven't done any problems like this yet this year. We have in the past, but not this year, so please watch carefully. In none of the previous problems have we had a parentheses with an exponent on the outside all by itself. Okay? So watch carefully what we do. This should be review from Algebra 2 and Algebra 1. First of all, notice the 2 has an exponent of 1, even though you can't see it, and so does the x. Anytime you have a group raised to a power, you take that power and you, hold on one second, again the mimeopad is messing up. You take this exponent and you multiply it through the parentheses, like this. Now, what I would end up with is, get this mouse real quick, would be 2 to the 3rd power. I'm using my mouse right now, so excuse me while I do that. My computer pen's not working. There. We would have 2 to the 3rd power and x to the 3rd power, because what I did is I took 3 times 1 and 3 times 1. All right? Okay, now let's go ahead and keep this group right here in parentheses, if you will. I guess we don't have to. We could just put a little dot there. It doesn't matter. Now, we have a 2 outside the parentheses here. The 3 has an exponent of 1. The x has an exponent of 1. We're going to take this 2, and we don't add it. We multiply it through times all the exponents. So I end up with 3 squared and x squared. Now, let's use a little common sense here. Obviously, 2 to the 3rd power, 2 times 2 times 2 is 8. And obviously 3 to the 2nd power is 9, which is 9x squared. And now we're ready to go ahead and simplify. We have a coefficient of 8, a coefficient of 9. Let's go ahead and multiply those together, and we get 72. And then we have a base of x and a base of x. When you're multiplying like bases, you write the base once and you add the exponents. And we're finished. Moving on to number 29. All right, 29, kind of the same thing as the last problem, only be careful with this negative sign. They're really trying to trick you here. I want to warn you, okay? Now the negative 2 has an exponent of 1, and the n has an exponent of 1. We have a 3 on the outside of the parentheses. We're going to multiply that 3 through times all of the exponents. But watch what I do here. This negative 2 is negative inside the parentheses, so you got to be very careful. You've got to put negative 2 to the 3rd power, n to the 3rd power. Now some of you, maybe all of you, most of you are going to really struggle with that concept. So let me explain it like this. This negative 2 right here is inside the parentheses, and this 3 is on the outside, okay? This 3 not only goes to the 2, it goes to the negative 2. So you've got to keep that negative 2 in parentheses. Because if you don't, sometimes it will cause you to miss the problem, okay? Now let's go ahead and take this a little further. We have negative 2 to the 3rd power. The negative 2 is in parentheses, so that means negative 2 times negative 2 times, let me get my negative sign there, negative 2. Negative 2 to the 3rd power is negative 2 times negative 2 times negative 2. If you have to use a calculator, that's fine, that's up to you. But you would get negative 8 n to the 3rd power, because negative 2 times negative 2 times negative 2 is negative 8. Now over here, the 5 has a power of 1, the n has a power of 1. We multiply the 2 through, and we're left with 5 squared n squared, which would then be 25 n squared. Okay? So now we're ready to go ahead and finish the problem. We have an expression times an expression. We have a coefficient of negative 8, a coefficient of 25. If you multiply those together, a negative times a positive is negative. 8 times 25, I'm doing in my head, 40, 16 should be 200. And then n to the 3rd times n squared, you're multiplying like bases. You write the base once and you add the exponent. So there we go. The answer is negative 200 n to the 5th power. Okay, now let's continue on to a concept we have yet to have learned. Well, excuse me, this year. We learned this in Algebra 2, and hopefully you know this concept already, students, but here we go. The concept is simply like this. Are you ready? Whenever you're dividing like bases, and this fraction bar does mean divide, hopefully you guys know that, I have a base of b and a base of b. Well, there's a property that says this. There's a property that says whenever you're dividing like bases, you go ahead and write the fraction bar, and you write the like base in the numerator, always up top, always. And then you subtract these. You always take the top number minus the bottom number. Let's go over that again. Whenever you're dividing like bases, like I have a b here and a b here, the property states that you write the like base, which is a b, you write that in the top, the numerator, always. You write it one time, just like this, and then you subtract. You always take the top number minus the bottom number. So 40 minus 37, all right? Now when you do that, obviously 40 minus 37 is 3. Now when you do that, there's nothing left in the denominator, so we just put a 1, and of course anything over 1 is just itself. So there's the answer, not too bad. Let's go over that for a third time. Whenever you're dividing like bases, you write the base once in the numerator, and you subtract the bases and write that up top, and you're finished. Let's try number 33. Okay, good. The same problem. I like this. We're getting a lot of reviews. Okay, we're dividing a base of x and a base of x. So the property I just taught you is when you're dividing like bases, you write the base once in the top, and you subtract the exponent. So negative 5 minus 16. Well, negative 5 minus 16 would be negative 21. Okay, so I have x to the negative 21, and of course that's all over 1. Now, you say, Mr. Earhart, in that last problem, it was all over 1, and this problem, it's all over. Why is it all over 1? Well, students, because when you divide like bases, what I said is you write that base once in the numerator. You do not write it in the denominator again. Same thing in the last problem. Whenever you're dividing like bases, you write that like base one time in the numerator, not in the denominator, okay? Now, we think we're done, but look what we have. We have one of those negative exponents, which we do not want to have. So what we're going to have to do is we're going to have to bring this x to the negative 21 down to the bottom, like we learned earlier this class period, so that the negative 21 becomes positive, all right? So when we do that, we have x to the 21. There's nothing left up top, so I'm going to put a 1 there. And that is your final answer, 1 over x to the 21. Okay? All right, let's move on to number 35. We're getting pretty close to getting done, guys. We got, what, like 14, about 8 problems left. It's not bad, okay? We've done pretty well. Now, be really careful here, okay? We have a like base of x and a like base of x. Are you ready? Watch carefully. When you're dividing like bases, x and x, you write the like base one time in the numerator, so I did that, and you subtract your exponents. 2 minus, be careful, we have two negatives, 2 minus a negative 1. 2 minus a negative 1. Well, if you need a calculator, that's fine, or if you can do it in your head, you do know that 2 minus a negative 1 is 3, so we have x to the third. Now, let's continue on. I took care of my x's. I'm going to go ahead and cross those off. Now I'm dealing with my y's. I have y to the negative 2 over y to the 1. Now, when you're dividing like bases, a y and a y, you write the like base up top, and you subtract the exponent. So I have negative 2 minus 1. Well, negative 2 minus 1 is a negative 3. Okay? So, now, I would normally be done, but notice I do have a negative exponent. Does the x have a negative exponent? Well, no, it does not. It's a positive 3. Does the y have a negative exponent? Yes, it does. It has a negative 3. And so I'm going to bring this y to the negative third down to the bottom. So now I have x to the third over y to the third. And that's my final answer. There's nothing else I can do with that. Okay, let's take a look at number 37. Now we're getting into some really good problems, okay? So I hope that you'll pay attention and watch carefully what to do. Okay, notice on this problem, unlike the last problems we've done, we have some coefficients. We have a 32 out in front of your variables, and we have a 4 out in front of your variable. So let's talk about those. First of all, you always want to reduce those if you can. Now, what's the biggest number that goes into 4 and 32? Well, 4 does. 4 goes into 4 once, and 4 goes into 32 8 times. So I'm going to put an 8 right here and a 1 right here. Okay? All right, let's cross those off. We're done with those. Now let's look at our x's. We're dividing an x into x. So when you're dividing like bases, you write the base once up top, like that, and then you subtract the exponent. So we have negative 4 minus a negative 5. Negative 4 minus a negative 5. Now if you're weak with your sign numbers, then you'll want to use a calculator. That's up to you. But you should get a positive 1 when you subtract those, okay? So x to the positive 1. There, I'm done with my x's. Now let's look at our y's. I'm dividing like bases. Whenever you're dividing like bases, you write the base once in the numerator, and you subtract the exponents. 3 minus 8. Well, 3 minus 8 gives you a negative 5, so I have y to the negative 5. Now, normally you would be done, students. However, notice we have a negative exponent. Now, does the 8 have a negative exponent? Well, no, its exponent is 1. Does x have a negative exponent? No, it does not, but y does. So we're going to have to take this y to the negative 5 and bring it down to the bottom. So in the numerator, I'm left with 8x. Okay? Now if you want to put those ones with them, I have no problem with that. You don't have to. That's up to you. And then in the bottom, you would have y to the positive 5. Now, do you see this 1 right here in the bottom? You are more than welcome if you want to put that 1 right here. I don't care, but you do not have to. So there's your answer. 8x over y to the 5th. And that would be number 37. Let's take a look at number 39. Well, this was not bad at all, students. This is pretty easy, actually. Watch this. My b has an exponent of 2. My a has an exponent of 1. My 2 has an exponent of 1. And what did we learn? Let's go back about 5 problems here. Remember when this 2 was on the outside of the parentheses right here? We multiplied it through 2 times 1, 2 times 1. Hopefully you remember that. We just did that about 10 minutes ago. Well, let's do the same thing here. We have an exponent of 3 on the outside of the parentheses. So we're going to take this 3 and we're going to multiply it through times all of the exponents. Okay? So let's see what happens. 3 times 1 is 3, so I have a 3 here. 3 times 1 is 3, so I have a 3 here. And 3 times 2 is 6, so I have a 6 here. And now what is 2 to the third power? Please don't put 6. 2 to the third power means 2 times 2 times 2. And 2 times 2 times 2 is not 6. 2 times 2 times 2 is 8. A to the third power, b to the sixth power. All right? Nothing else you can do, students. Look at it. I've got an a, a b, a coefficient. There's no negative exponents. We're good. We're going to go on to number 41. Now, please be careful on number 41. The x has an exponent of 3. The 2 has an exponent of 1. But notice the 2 is negative. So when we take 5 times 1 in just a second, we're going to put negative 2 in parentheses and then a 5 on the outside, because you do want to keep that negative sign with the 2, and then x to the 15th power. And where'd the 15 come from? 5 times 3. 5 times 3. Okay? All right, here we go. Now, negative 2 to the 5th power. If you want to use your calculator on this, please don't type it into your calculator like this. Okay, you don't want to do that. You do want to use parentheses. Sometimes you'll get out the right answer, sometimes you won't if you don't use parentheses the correct way. You want to type into your calculator negative 2, and then if you have a TI grapher, you hit the arrow button so it looks like this, and then you hit 5. Negative 2 to the 5th power is negative 32. If you want to do it the long way, it'd be negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16. And positive 16 times negative 2 is negative 32. Either way, you get negative 32. Negative 32 what? X to the 15th power. That's it. There's nothing else you can do. Not too bad. Okay, number 43. Now we're getting a little more difficult, so let's really pay attention here. Let's take our negative 2 and let's multiply it through. The d's exponent is negative 2, the c's exponent is negative 1, and the negative 5 exponent is 1. Now when we take this negative 2 and we multiply it through, we're going to go ahead and keep a negative 5 in parentheses, and then we're going to have a negative 2, and then we're going to have c to the positive 2, and we're going to have d to the positive 2. Is everybody with me on that? A negative 2 times 1 is a negative 2. A negative 2 times a negative 1 is a positive 2. And I made a mistake, didn't I? A negative 2 times a negative 2 is a positive 4. Sorry about that. And knowing me, there's probably been other mistakes in the video also, so that does happen sometimes. All right, now let's take a look here. The d has a positive exponent, the c has a positive exponent, but look at this. The negative 5 does not have a positive exponent. The negative 5 has a negative exponent, okay? So we're going to have to move this whole expression down to the bottom of the fraction. So we're going to put a fraction bar. We're going to leave the c squared up top, the d to the 4th up top, and in the bottom. Now you know what a lot of students do? They change that negative 5 to a positive 5, and you're not supposed to do that. The only thing that changes when you're moving variables or coefficients from the top to the bottom or the bottom to the top, the only thing that changes is the exponent, not the base, okay? So we have c squared d to the 4th over negative 5 to the 2nd power. Now, negative 5 to the 2nd power, think about that. Negative 5 squared means negative 5 times negative 5. And that would be a positive 25. And up top, we still have c squared d to the 4th. All right? And there we go. That is the correct answer. And we're almost done. 3 more problems. So we're just about finished. Okay? Let's move on to number 45. Now, this one's going to be pretty simple, I believe. You have m to the 4th power, 3 to the 1 power. Let's take our 3 and multiply it through. 3 times 1 would be 3. And 3 times 4 right here, 3 times 4 would be 12. That's easy enough. And then 3 to the 3rd power, 3 times 3 times 3 is 27m to the 12th. Times, now let's work on this group. I have m to the negative 5 and 2 to the 1. Let's take 4 times 1. That would give you 2 to the 4th power. And then 4 times negative 5, that would give you m to the negative 20. Hopefully you're seeing where these numbers are coming from. Now, I have 2 to the 4th power. That's 2 times 2 times 2 times 2. That would be 16. 16m to the 20th power. Very good. And now we should know what to do, students. We have 27m to the 12th. And actually, I apologize, students. That should be a negative 20 right there. There we go. We have 27m to the 12th times 16m to the negative 20. And let me grab my calculator real quick here. First thing we're going to do is we're going to multiply our coefficients. We have a coefficient of 27 and a coefficient of 16, so we're going to multiply those together. 27 times 16 would be 432. And then we're multiplying like bases, a base of m and a base of m. Whenever you're multiplying like bases, you write the base once and you add the exponents. So m to the negative 8th. All right, so with that in mind, I'm almost finished, but look, I've got a negative exponent. Now, does the 432 have a negative exponent? No, it does not. It has a positive 1. Does the m have a negative exponent? Yes, it does. So I'm going to have to move this m and the negative 8 down to the bottom. So I would now have 432 over m to the positive 8. And that would be your answer. 432 over m to the positive 8. Okay, let's move on to number 47 and number 49, and we'll be finished. Wow, okay, now watch carefully. I've got a really big parentheses around an entire fraction, so, and with a 3, a power of 3 on the outside. Now what that simply means is this 3 gets multiplied times all of the exponents on the inside here, okay? Now, X has an exponent of negative 3, Y has an exponent of 7, Z has an exponent of negative 1, 2 has an exponent of 1. So let's take this 3 and multiply it through. 3 times 1 would give us a power of 3. For your X, 3 times negative 3 would give us a power of negative 9. For your Y, 3 times 7 would give you a power of 21. And for your Z, 3 times negative 1 would give you a power of negative 3. Now, students, let's think this through for a second. First of all, 2 to the third power. 2 times 2 times 2. Well, that's 8. And then look, why would I move the Y? The Y has a positive exponent. Leave it where it is. But look at the Z. I've got to bring this Z up top. Do I not? And make it a positive 3. And look at this X. It's got a negative 9. I've got to bring it down to the bottom and make it a positive 9. And now we're finished. It looked really difficult, but that's not too bad. That's really not too bad. All right, let's take a look now at number 49. Wow, someone had way too much free time to make this problem. Number 49. Okay, we're going to take this negative 5. It goes to everything inside the parentheses. So my 24 has a power of 1. A has a power of 10, B negative 8, C 7, C 5, B negative 3, A 6, and 12, 1. Let's take this negative 5 and multiply it through. So I would have 24, negative 5 times 1 is negative 5. Negative 5 times 10, it would be a negative 50 for the A. Negative 5 times negative 8 is a positive 40 for the B. Negative 5 times 7 would be a negative 35. So there, I have taken care of the entire numerator. Now let's talk about the denominator. We have 12 to the 1 power, so negative 5 times 1 would give me 12 to the negative 5. A to the 6 times negative 5 would be A to the negative 30. B to the negative 3 to the negative 5 power would be B to the positive 15. And then C would be negative 25, because negative 5 times 5 would be negative 25. Now, students, when I look at this problem, and believe me, it looks pretty difficult. When I look at this problem, I'm like, you know, I've got a lot of negative exponents. And since I have so many negative exponents, maybe I should first of all move them to make everything be positive. That might be a smart thing to do. Okay, so let's go ahead and try that and see what's happened. I'm going to move the 12 up top. That would give me a positive 5. Bring the A up top. That's a positive 30. Leave the B down the bottom. That's B to the 15. And bring the C up top. That's a positive 25. Do y'all see what I did? I brought this up top, left this in the bottom, and this is up top. Now let's look at the top. I'm going to bring the 24 to the positive 5 down to the bottom. I'm going to bring the A down to the bottom. I'm going to squeeze it in right here, really small, A to the 50. Notice I'm making the exponents negative. Now B to the 40 is positive, so I'm going to leave that up top. B to the 40. And then C to the negative 35 comes down here. C to the positive 35. Now, if you will let me very quickly do a quick little cut and paste. We're going to move this to another page and do some more work with it, okay? So hold on 1 second while I do that. All right, there we go. Now, this is what you should have in your notes, okay? Or in your homework, whatever you want to call this. So what I'm going to say next is this. 12 to the 5th power and 24 to the 5th power, those are some really, really big numbers. And all I can say to you is this is when you really need a calculator. I mean, we're going to get something like 248,832, and 24 to the 5th power is going to give you a really big number too. So just trust me on this. You should be able to take a graphing calculator and type in, now listen, 12 to the 5th power divided by 24 to the 5th power. You should be able to do that. And then hit enter, and then reduce it, and you should get this right here. I'm going to do it very quickly. Enter, divided by 24 to the 5th power, enter, and you should get 1 over 32. Now, if you have any questions on that, we can talk about it when we meet during that one time. But when you take 12 to the fifth power, you're getting a really large number, like 248,832. And when you're taking 24 to the fifth power, you're getting a really big number, like 7,962,624. And if you'll reduce those two numbers, your calculator will reduce that for you. You will get 1 over 32. Now, I know that's a lot of work, but that's why I use calculators in Algebra 2, and that'll save you a lot of time, okay? All right, so when you reduce those two numbers, you do get 1 over 32. Now, we have a to the 30 over a to the 50. Now, listen, students, we learned this about 15 minutes ago. Whenever you're dividing like bases, you write that base one time in the top, and you subtract the exponent. So 30 minus 50. Negative 20. Now let's look at your b's. I have b to the 40 over b to the 15. While you're dividing like bases, you write the b once in the top, and you have 40 minus 15, the top minus the bottom. 40 minus 15 would give you 25. Now let's look at your c's. You're dividing like bases, so you write your c right here. 25 minus 35 would be negative 10. And finally, what a beast of a problem. Finally, we can now move things around to get rid of our negative exponents. Now the 1's going to stay right here, the 32 is going to stay right here, and your b, it has a positive exponent, so your b is going to stay right up top. However, your a has an exponent of negative 20, so it comes down to the bottom, and your c has an exponent of negative 10, so it comes down to the bottom, and that is your answer. Now, if you do not want to put that 1 right here with the b to the 32nd power, you don't have to. You could just have b to the 32nd over 32, a to the 20th, c to the 10th. That's totally fine. If you want the a to stay, the 1 to stay there, and do this, that's totally fine. Now, students, here's what you've done. That's it. That's your lesson, your homework, all tied together in one big session. And I believe it was less than a grand total of 50 minutes, I believe. And that's really good. I mean, look, normally a class period alone at a regular school is 50 minutes, plus you have about 30 minutes of homework every night. So we did it all. That was our lesson. That was our homework. That was everything for today, August the 14th. And that's reviewing. Let's go way back up to the very first slide, way back up to the top. What did we do today? We looked at exponential properties, review lesson 2, page 14, 1 through 49 odd. Okay? All right. Hope you guys are doing well, and we will learn some more math tomorrow.